My name is Tomek Szymański,
My name is Marcin Grzejszczak.
and today we're going to talk about microservices, but we don't want to talk about the theory. This time we're going to talk about actually coding them.
So to begin with, because I'm not that famous as Shimano is, so I'm going to say a few words about myself. For those who don't know me, my name is Marcin Grzejszczak. I'm a software architect for finance IT. I really like testing, so I wrote 2 books about Mockito actually, but yeah, since you can use Spock, so why should you use Mockito? So I should write another book now. Speaking of which, I really like Groovy. Together with Shimano, we're organizing also Groovy user group. So since I really like Groovy, I wrote an AST transformation called Builder in Groovy Core. And we really love microservices. That's why we wrote a library called MicroInfraSpring. I think Josh Long even said about some things about this library. And as for finance, we are committers to Spring Cloud Zookeeper and Spring Cloud Sleuth. And there you go. You can see my Twitter handle and my blog and my homepage.
Okay, my name is Tomek Szymański, also known by the nickname of Shimano. I've co-founded 5 years ago SoftwareMill. Not so small company now, that's fully remote, but I'm lucky enough to be still coding. And the whole reason for today's presentation is that I've been working for finance.
For finance.
For too long, for finance. And we've been working together with Marcin. We laid out the basics of how the microservices are done there. So we want to talk about how it's done. You can see my Twitter handle, my blog. Yeah.
And the whole presentation, the setup, the infrastructure would never take place if it wasn't for this guy, Łukasz Szczęsny, who is our DevOps for Finance IT, and he really loves, Linux automations and stuff. So all the tools that we're going to talk about today are there thanks to this guy. You should follow his Twitter, blog, and whatever because he's really awesome.
But he hasn't written them.
What?
He set up it. He hasn't written all those tools.
He set it up.
Yeah.
So, yeah, this is our setup. Don't be afraid. We're going to go through this step by step. So, to the top right corner, it's our starting point. Because when you're about to create some microservices, you should write some code, right? So, when you're pushing the code, it should be built by something. In our case, it's going to be Jenkins. This Jenkins, it's not actually clicked since it was provisioned. And also not a single, one job was actually clicked and the rest was generated from the code using Jenkins job DSL plugin. Really, if you're using Jenkins on a daily basis, you should start using this plugin. It's awesome. Next thing, so Jenkins building stuff, producing jars, testing, and then it calls rundeck, which is a process also that takes configuration from Git. And rundeck is delegating the deployment to a proper server. So Jenkins says, for example, this application deploy to that server. So we go over here. Here you have the services that we're going to work with. What is crucial, we don't want to have the configuration of the services in some files that people can modify without any, let's say, control. Of course, we never did that on production. Nobody did it here for sure. That SSH to production change one.
Who has never done it?
Yeah, of course. Nobody will say so, right? So what we wanted to achieve is that we have the properties in Git. They are stored there. They are auditable, secure. Yeah, and what happens next is that those applications are producing logs. So there is a application called Logstash Forwarder, which is taking the logs and putting them to the ELK stack, so Elasticsearch Logstash Kibana stack. And over there, all the logs are gathered, and you can see them, view them, query them in a very nice manner. On the other hand, we are also collecting metrics, business metrics, technical metrics, and they are sent to Graphite, and we have a cool UI for Graphite called Graphana, and there's some database underneath as well. And what is crucial is that, of course, you can, let's say, plot the graphs related to metrics, but they don't make much sense if you do not have alerting, and that's why we have Siren over there, which is a tool alerting tool that hooks up on graphite metrics, and if some thresholds are met, some action is taken. In our case, in the case of this presentation, what happens is that we are sending it to Slack, because we have bound both Jenkins, Siren, and Isinga to the top in Slack. So we have one tool for communication for all of the people, all of the teams, and they have different notifications from different places. Isinga is a fork of Nagios. This tool is used for monitoring health of our applications. So there is a ping on the health endpoint sent to check if an application is up and running. Another monitoring tool is Hystrix dashboard. Since we're using Hystrix, who knows what Hystrix is? Okay, quite a few people. So we're going to go to that in more details afterwards, but we have a dashboard to show the state of commands, of Hystrix commands. Another really important thing is that when services talk to each other in a distributed system, we don't want to hard code URL and ports. That's why we have service registry and discovery via zookeeper. And all of that with the A sign means that it was provisioned via Ansible. So it has not been, it hasn't been like, SCP or wget by one of the DevOps, but it was automatically provisioned.
Yeah, and all that infrastructure is open sourced on GitHub, all the Ansible playbooks, so you can set it up on your own machines if you want to. Now, who's lost? Hands up? Okay, no one. But if, okay, you are lost. Don't worry, we're going to go step by step now, showing code and then the services, how they actually work. Okay, so let's get to the coding. Just a few words what we're going to code. What we want to do is a brewing production line. So imagine you have a brewery. Now, if someone knows anything about brewing beer, then you'll probably find out we do not know nothing. But this is how we think it might look like. So we have 4 components, and this will be our microservices trademark. The first one is the presentator. The names are somehow Polish and English at the same time. Mind blown. So presentator is something that will be just the controlling component with the UI. You'll see where are the business processes at the moment, and it will also allow you to interact with our system by placing orders. The orders will go to the service called aggregator, and the aggregator is the aggregating service that will call external services that are used to order yeast, malt, water, and hop. The 4 main ingredients of a beer, and it will store them in a stock. And once there's some threshold met, we'll send these ingredients to another component, which is called dojrzewator. This is the maturity component that is used to mature the beer, and the thing that is maturing is called wort. Which is brzeczka.
Brzeczka.
Yeah, and so once this is done, the beer can be sent to the 4th component, which is the butelkator, which is the bottling service, and it will bottle the beer, and will send the beers to the warehouse. And in the presenting controller, the presenting component will see how many things are being ordered, how many things are being matured, how many things are bottled, and how many bottles do we have. Okay, so that's it for the presentation and the slides, except for the thank you slide. Let's do some coding. So let me toggle to the presentation mode. Okay, people in the back, can you see the yeah? Okay, I can't see you though. Okay, so now let's go with the model. I think it's okay. So the model is quite simple. Oh no, actually, before we go to the model, we need to talk about the API.
Who has been to the presentations of Mr. Lewis? He was talking about Pact. Actually, there's a better tool. And yes, I'm the co-author of this tool. That's why I think it's better. It's called Accurest. In this, what you can see is the definition of a contract. Since today you could hear about consumer-driven contracts. Actually, when we wrote the whole setup, we did exactly the same thing. What you can see here is the let's say, template of a contract on the aggregator side. So let us assume that the whole setup that we've shown to you, so those 4 services, were created by 4 different teams. So the presentator team wants to access aggregator's resources, its API. So they, since they are the consumer of aggregator, they present such a contract. And what you can see is a definition in Groovy DSL. It's statically typed, so no dynamic magic over there. And what you can see is that for a request with method post on a certain URL and certain headers, we are versioning the API. So you can see here version 1. And certain body, some response is going to be returned. So status to 100 and body with ingredients and different types and quantities.
Yeah. So we're going to send the list of the things we want to order from the external services. The aggregator is supposed to order them and then get back with the information how many are there on stock, including the ones they ordered before. Okay, so once we have that, they send us this. Now we need to be the architects, so we need to be very smart and use words such as resilient and scalability. And once they feel they stupid, then we can start coding. Okay, so this is the model.
It was a joke.
You should laugh, but no, it didn't work. Thank you. Thank you. Next time. Okay. So we have the model. Most of the service is done because we wouldn't have time to code everything from scratch. So we have a notion of a few things. The first thing is the ingredient, which has the type and quantity. The ingredient type is one of the 4 basic ingredients that we're going to use for a beer. Then we have something that wraps the ingredients into the list. So this is something that we will return once the orders are made. And also there's order, that this is the message that we're going to get from the presentator, which is just a list of the ingredients that are supposed to be ordered. And then we also have something called version. For now, we're just going to use the aggregator v1. This is the trick that we use for versioning the API. Just in the content type of the service that we're going to expose, there will be the version part coded. So if someone is trying to talk with our service with another version, it will just fail. Or we have to implement all the versions. Okay. So now there's a very sophisticated database that is done on a concurrent hash map in the memory. So it's just used to storing those ingredients. As I said, this is a service, so it should be a singleton bin in our case. And we'll have our controller, which is a simple Spring REST controller. We're going to expose it on the ingredients endpoint. This is the same endpoint that we saw in the Accurest specification. And this is the version that we're going to consume. So we're going to expect v1 version right now. And we'll have one method, which is the post method. Again, the same on the Accurest. That will take the order and return the list of ingredients. This is our service that we're going to write now, or just parts of it. So what it has here, there is some metrics set up to send them to Graphite. But the important business logic is here. Oh, so before we continue, there's something called ingredients properties. This is something, the setup, basically configuration of our service. We'll have a map of all the ingredient types mapping to the proper external service. There is no hop ordering service, obviously, available, so we just mocked it. It's going to reside on localhost 8030 under /vodeo, swodeo, chmieleo, and drożdżeo. And what we did here is we used wiremock server, which is just taking a JSON, and then it will expose whatever is specified in the JSON. I can show you one of the JSONs. So basically, there's going to be a get method on the Vodeo that will return always 1,000 quantity of water.
WireMock is an HTTP server stub because we don't want to really call a Vodeo service because there is none. So we needed to stub it in memory. We used WireMock for that since we are also using it on production. So.
Yeah. Okay. So let's start coding. Now, Marcin.
So I'm going to be like talking about what Shimano is going to write. So basically, since our controller is going to receive an order, we will have to, of course, using the buzzwords like resilience and multi-threading and concurrency and whatever, we're going to call in parallel as many services as there are in the order. So if in the order there are 3 services to connect to, we're going to connect to those 3 only. So what we're doing right now is that we are mapping the name of a type, for example, hop, to an external name like drożdże or whatever. And we're going to harvest this, ingredient type from this external service. Who is using Java 8 on production? Well, quite a few people. And the rest, what are you waiting for? Come on. How can you write without this? So, so this is the first thing. As you can see, we are using futures because we can, and why should we block at all, right? So we have a list of listenable future of ingredients. Right now, since we are in this example, in this microservices, we are using the framework that we built, so it's called Microinfra Spring. We have an abstraction over REST template in Spring. Whoever worked with REST template knows that it is terrible to work with. So we wrote a Fluent interface to let's say, wrap the whole terrible stuff underneath our abstraction. So it's called Service REST Client. So for external service means that we're not going to call a microservice, but some external service somewhere in the world. Retry using means that we're going to do some retries, makes sense. So a separate thread pool is created underneath. We're going to send a get method with circuit breaking. So underneath, we're going to wrap the execution with hystrix. What does it mean? It means that if the other side is not working, hystrix will work like this, that it's not going to... we're going to provide a fallback method, which means that if the other side is dead, hystrix will not allow to send a real request to the dead endpoint, but it's going to return immediately with a fallback method. In our case, we discussed it with the business that we're going to just log an information that we cannot connect to an external service, and we're just going to return nil. Next, we have to send some URL. We have to send the request to some URL. It's like Shimano said, a concatenation of the root path together with the name of the service, for example, Vodeo for water.
Oh, sorry.
Oh, sorry. Okay, so now we should return something actually from this Fluent interface. As you can see, syntactic sugar is awesome, like in Rest Assured, more or less. So we have to execute for an object of type async because we don't want to block. Right? We want to send, for example, 4 concurrent requests to 4 external services. Okay, so we have a list of listenable future, and right now we can do some Java 8 magic and change a list of listenable futures to a listenable future of list. Why do we want to do that? Because actually, at the end of the day, we want to block somewhere, and if we were going to block to return a value, we want to actually have a list of ingredients at the end of the day, right? Because we're talking to external systems, we're gathering data, and we want to bring it back to the user. So we're changing the list of listenable futures to a listenable future of list, and we're going to block. Who is lost? Nobody, that's cool. Okay, so here we blocked, so actually maybe we have already received the request, or right now is the time to block and wait for the stuff to come back. Since we might have received a null value, we have to filter it out. That's why we can use lambdas to do it in a cool way with filtering. And then we do what? We have to store it in the warehouse, right? Since we have this awesome database as a hash map, so we have to take the ingredients from external services, do it in parallel, block when needed, and store it in the database. So we just will call ingredient warehouse add ingredients method, and that's it, because we are sending back to the client the current state of the application. So that was the first part of the live coding. Shimano is awesome. And yeah, it should even work, I guess.
Yeah, so now, moment of truth. I'm going to commit it and push it. Blah,
Hopefully
blah.
the internet works properly. And what happens now is that we're going to commit and push the code. In the meantime, there is some polling going on Jenkins that it's checking for the changes on the GitHub side, because all of our code is available at GitHub. And Jenkins should start building. This is our pipeline. All of that, what you see here, is actually done from the code. Right now, anytime it should start, but we can also click it to make it faster. And right now you can see an execution of the pipeline. The pipeline is very sophisticated because it's building, creating a jar, putting it to Nexus, and then in the second stage it's calling rundeck and telling the guy, deploy it to the production server. In the meantime, we can go to Slack and see an information by Mr. Jenkins that aggregator is being built. Actually, for finance we have HipChat, but this is like the very same thing. So it's being built, there's information about the changes, and we should deploy anytime.
It's deploying to production.
Yeah, it's deploying to production. We have a cool deploy to production monitor, so you can see all of the services and let's say their current state in terms of deployment to production. Okay, it's there.
It's starting even.
Of course.
Okay, now we can see also the exhibitor.
Okay, we're talking about this, that all the applications that we have, when they talk to each other, they do not talk directly, they go via zookeeper. What does that actually mean? Here you have a UI over zookeeper, it's called exhibitor. And then you have the information about instances and their names. So actually you can see PL Devox aggregator, and this aggregator has a UUID, which means that it has registered itself in zookeeper. For those who don't remember, zookeeper is the service registration and discovery tool, which means that if we click there and scroll down.
Well, this is not found because we caught him in this small time window where the old one was going down and the new one was already up. So the old one did not time out yet. So it sees that there were two guys registered, but by now it should be timed out, and there should be only one instance. Oh, okay, here it is.
If we go down, we're gonna see that actually there is an address and there is a port. Oh, I can click it over here, right?
Yeah.
So it's hidden to the user. The user just says, I want to talk to a guy called aggregator. And underneath the magic appears and an instance is taken. You can register multiple instances under same name, and that's how you get load balancing. The very same thing is when you're using Spring Cloud and Eureka. That's the very same notion of the service registration and discovery.
Yeah, by default this will be round robin, but you can configure it. Okay, so this is our control panel I talked about before. So we have basically here's on the left. You can see the state of the stock. Right now we just restarted everything, so it's on 0. We don't have anything. We need to order. Then you'll have the how many processes are maturing. Then how many processes are bottling. And then once they're bottled, we're gonna see the number of bottles increasing. So now I can place an order, and you can see that it has ordered everything. I can order only parts. And basically, right now, there's still no connection between the aggregator and the derivator, so we can only order. I can automate it, and you can see, maybe we'll make it faster. So you see there's a lot of things on stock. Yeah, So I guess this is it for that part. So let's actually connect those two. There should be also some alerts. Yeah, you can see that once when the aggregator was down, we got a notification from Nagios that there was something wrong with it, and it's okay now. And Siren is also monitoring us that at some point the ingredient amount was wrong.
So those, because there's, as you can see, we used a lot of different words for different tools. So as a recap, Siren is a tool used for alerting in terms of metrics. Here you have a metric called apps.pl, aggregator, apps, ingredients, whatever. It means that we're checking the stock of, let's say, the quantity of the things in our warehouse. We wrote such a rule that if we go below 1,500 on any of those items, we should present a warning message. And if we go below 500, then we should send an error message. Siren is a very simple tool to provision. It's a simple jar, and you can integrate it with many other tools like HipChat, Hubot, email, whatever.
Okay. So now, before we use service REST client to call an external service, but it was a boring example. Now is the more interesting example. You saw that every microservice is registering in Zookeeper under some path. And right now we're on aggregator. You can see that it will register on this path. But what we want, who we want to call is the Dojrzewator. Shut up. Dojrzewator. And basically here, we're going to put him into the dependencies. And this will be the ID that we can use in our code, not to have to change the path every time that something changes. We move around microservices. So let me just copy it like that. Okay, so now Dojrzewator should be available. And it will, sorry? Dojrzewator. Yeah, Dojrzewator. No, it doesn't have O because I don't know.
We're hipsters, right?
There's no O. So there's Dojrzewator, aggregator, butelkator, presentator. That makes sense. So let's code it.
Okay, so we're coding right now the second feature, which is we'd like to call Dojrzewator to tell the guy that, hey, we reached a certain threshold with our ingredients. By default, it's 1,000 per each of the ingredient types. And now, Mr. Dojrzewator, please start maturing the beer. And we should also, let's say, lower the quantity of ingredients in the warehouse, right? Makes sense. So we're taking the ingredients, dropping it by the threshold amount, and telling the maturing service to start maturing the beer. So, service REST client again, so abstraction of a REST template for service Dojrzewator. This is the very same name that you saw in this JSON file. You remember there was a alias Dojrzewator and some path. So in order not to write the path, we are writing the alias Dojrzewator. We also want to be resilient and all the buzzwords. So again, we are using the retry using to have a thread pool prepared. Post, because we're going to send a post message. And circuit breaking again. Here we are showing actually another case where in Hystrix you don't have to always provide a fallback method. In this case it won't be there, so when the other side is, let's say, down, an exception will be thrown. But we're wrapping it in the Hystrix command, so we get all the metrics related to Hystrix and all the, let's say, benefits that Hystrix gives you. We're sending it on URL/brew, and we're sending this time the body. In the service REST client, you have fluent interface, so the compiler tells you what kind of methods you can have. So in this case, when you're posting, you can, it makes sense to send some body, whereas with the get, you don't. We're placing the version this time, because we're calling one of our services, and we are versioning our API, and everybody should be versioning his API. And we don't care about the response, and we don't want to block, so we do ignoring response async.
Yeah. So you can now we need to call it actually. So you can see there's a method called update if limit reached, and what it basically has to do, once it will get the list of the ingredients that are on stock every time that something changes, and if they match the threshold, in our case it's 5,300 for each ingredient, it has to notify the dojrzewator that the beer has to be brewed, and it has to take off the threshold from our warehouse. So this is our database, and our solution is almost thread safe. Sometimes we'll see it below 0. Yeah,
it's eventual consistency, right? When you have a warehouse, you can have minus something on as quantity, right?
Yeah. Very eventual. So okay, so the method that checks it basically is very simple. So we first check that the number of ingredients is the same as the number of all ingredients. So this is we have to have all 4, and then we check one by one that all of them match some check, which is that the quantity is equal or higher than the threshold that we have in the properties. Okay, so now we have to call it. So let's go again to our aggregator. So this will be the perfect place will be, I guess, here. So the dojrzewator updated. Here we have the list of all the ingredients that we return to the client. So before returning them, we'll check if we don't have to send them to the dojrzewator. So actually, when the client is notified with the number of ingredients, he'll already know that there's less because they've been sent already. Okay. So now one thing, I think I'm gonna just push it. So with full integration, I'm going to push it, and before it starts, I'll show you that on our, actually, toggle presentation mode, and on our, this is Buttercutter, sorry. I need dojrzewator. Okay, so this is the service that we're going to notify. And very similarly, as with aggregator, we have a DSL, the API specified with a DSL. So you can see there's malt, water, and hop. It takes some number. And the cool thing that we did is that once this is committed, that this is built, actually Gradle produces 2 jars.
Okay, so since we're doing micro-infra Spring and you're doing consumer-driven contract, the awesome thing is when, for example, my consumer, so the guy that I'm calling, changes his API, I would like to actually know about this, right? I mean, if it turns out on production, it's pretty late. So we bound in the building process that inside our micro-infra Spring library that during the tests, we are checking at Nexus for the latest stubs of the guys that we're going to talk to. And if we have an integration test, and it turns out that I'm calling the guy, and he changed his API, then my build is going to break. And that's precisely what should be done. Let's say it's going to happen on production. It will happen on production, so I prefer to fail fast. That's why Accurest with a plugin is transforming this Groovy DSL into a WireMock stub, and it's being sent to Nexus. Yeah. Here we have the, since we're doing TDD, as you could see, right, because we started from the code, we have Spock tests that prove that all our logic is okay. In this test, we're just doing an acceptance test in which we are sending the request to our service. Then we are retrieving the amount from the external services. So all of the ingredients are taken. And we put such a threshold that it's enough. So after the call, we are already, let's say, dropping the stuff that we had in the warehouse, and we should have 0 at the end of the day. So it means that the whole process with the brewing took place. And now you should ask this question, how on earth didn't we get an exception? Because actually we tried to call another guy because it's an acceptance test, right? So we booted up the application, we send a request, The threshold was met, so we called the Deutsche Water service. How on earth does it work? This is because microinfra Spring, that we downloaded during the test the Deutsche Water stubs, put it into in-memory zookeeper, and let's say we had the real information that the communication took place. This is pure consumer-driven contracts, together with the validation of both the server and the client side. Okay, so also in order to have a good way to develop stuff locally without setting up everything, which is the zookeeper, the dependencies, and so on, when you start your microservice in the dev mode, it will do exactly the same way, the same thing. So it will start the zookeeper in memory, and then it will download all the stubs of the dependencies and start them as wire mock servers and register them as well in the zookeeper. So you can actually click through your application if you're using some happy paths that are defined in the stubs. Okay, so by now I think that our thing should have deployed. So yes, you can see that Siren got first, it went to OK status because we ordered a whole lot of different ingredients. So they were a lot above 1,500. So it went OK, everything's fine. But then we restarted it, and so our in-memory database went to 0. So you can see it's on error again. So that should mean that actually it restarted. So now if I put order once again, okay, so you can see there's 1,000, 2,000. So let's click it. And now it should call the Deutsche Water. Let's see what happens. Okay, it's 700. And you can see that here there's one item. So now if we wait, what happens now is that it will time out for 10 seconds, which is the maturity. Okay, so zero items is here. Now the one item is on the bottle cutter. Now bottle cutter will, I think there's also 10-second timeout. And after 10 seconds, there's some magic formula that counts how many battles are done for how many ingredients. Maybe it's more than 10, maybe it's 15 seconds. Anytime now. So, but hopefully. Yeah, it's eventual consistency, resilience, buzzword.
Yeah. Oh, okay, you got it. So we have 600 bottles.
These are the bottles of beer that you drank yesterday. Buy for finance.
Okay, so now let's do something more interesting. So now it will start sending lots of orders. You can see that the thing here grows. There's 11, 12, 13. So up to the threshold start ending, and it will start sending everything to the bottle cutter. We'll see, okay, it's growing. So now I want to show you something called Hystrix dashboard, which will be, no, it's the wrong one, Hystrix monitor. Okay.
So what we can see here is like we said, we wrap the executions of calls to external service and to the microservices in Hystrix commands. So let's say in this part, you can see graphs related to commands being sent. I think only Tomek Nurkiewicz remembers all of the metrics and colors, what they do, but if you go to a certain number, it's going to tell you exactly what it means. For example, we have amount of commands per second, we have amount of currently processed commands. The big circle, the green circle means in general, what was the density of commands, how many of them were there. Below you have the names of thread pools. And what's the crucial thing is that the circuit is closed, which means that we are calling other guys and they are alive. So everything is in a healthy state.
Yeah, but now if I kill it, because I like killing things, so let's kill the Deutsche Water. But I guess grep missing. Okay, so let's kill this guy with sudo, of course. And now you can see, we should see that one of the executors. We should have put some meaningful names. Okay, so you see that already there's 100% failed requests, and after some threshold is met on Hystrix, then the circuit should open. Okay, so now what happens is that Hystrix found out that our external service is totally dead. And there's no point to actually try calling them because it takes time, takes your resources, takes your executor to thread pool, and so on and so on. So what it does, it will just open the circuit, and every time now we'll try to call that service, it will just return 404 immediately. Or 500, I don't know what's exactly what it's going to return, but it's just going to fail. And in the meantime, it's checking that maybe it's already up. So let's it's JJavator. So I'm just gonna redeploy it, and it will. Okay, so we'll go back to this later. Right now, the important part is we're not wasting time on trying to call that service. Okay, now Graphana. This is the which one do you want?
The first one.
The first one.
Okay, so here, since we said that we're collecting some metrics, and there is Siren, which is checking on the, let's say, metrics level of ingredients and so on and so forth. Actually, for finance, we have, where the teams are working, we have very cool TV screens in each of the rooms. And on each of those TV screens, teams can put the logs from their microservices and the metrics. And actually, the moment, for example, especially when you're working in a financial industry, when you can put on a graph how much money your application has made for the company, it makes really developers happy, and the business as well, of course. So what we can see here is a couple of dashboards with, for example, the amount of ingredients in the warehouse, the brewed beers, the bottles in progress, the beers bottled. And you can plot graphs from, let's say, months of data. You can do functions, all the stuff that is necessary for you to say that, let's say, the application is, just to have some trends, right? And you can progress things. Here you have more dashboards, this time related to the JVM, to the memory usage, to histories executions, to request stats. So you can put all of those stuff in cool, let's say, graphs, and then plot some trends. And especially what's the most important, basing on those metrics, you can do alerting. And during the talks, you heard about microservices, that, for example, you should ditch the integration level. For example, in our company, we are going that way, that we're not going to do end-to-end testing. But to do that, you have to do proper monitoring and do it on production, for example. You have to have metrics for that, and you have to have alerting.
Yeah. So, okay, so maybe I'll just switch that one off. So there's Graphana. Okay, let's see if Hystrix. Okay, so Hystrix was checking checks in the background from time to time if the service is alive, and the circuit was closed again because the service went up. You can see now that the graph went totally down because we switched off the ordering. So actually it reflects what happens. What I want to show you now is Kibana. Who has ever used it? Kibana?
Oh, quite a few people. That's awesome.
That's
so
awesome.
The rest of you is always grabbing the logs, SSHing to the servers. Yeah. So imagine when you have, for example, three instances, or let's be better, 50 instances of one application. And somebody told you that, hey, on one of the instances there was an exception. Can you please check the logs?
Yeah. Okay. And
which server are you going to SSH to?
Yeah. So for this particular check, we can use Kibana. It will aggregate all the logs from all the services. Here you can see which application is it from. So we will have the 4 that we have.
Can you increase the font?
Oh, the font. Maybe. Okay.
Can you see it? More or less?
More or less. Okay. Yeah. So now the interesting part, and this is something that we've also developed on top of Micro Spring.
And it's already been merged to Spring Cloud Sleuth. By the way, we've put a lot of stuff already to Spring Cloud Zookeeper, actually half of it, I guess. So as for finance, we're co-author of that. And into Spring Cloud Sleuth, the correlation ID, about which Tomek is going to talk right now, is also being merged.
Okay. So correlation ID is something that sticks basically to every request. in some path that the life of our business process in this case. And it doesn't change. So what we can do is the cool thing is that we can grab by it. So imagine that there is some interesting entry in our logs, and it says that the battles number was 37,410, and we want to see how it looked like the whole thing that worked. So this column is correlation ID. So I'm going to filter or tail by it, grab by it. Sorry. So here's this little loop. And you can see the whole thing that went from making a new order on presentator, sending it to aggregator. Aggregator actually ordered everything and figured out, okay, the ingredients match the threshold. We need to notify the Deutschewater. The Deutschewater was notified here, and it said that we need to brew the beer, and it notified the presentator that the beer is being brewed. And then it notified the Buttelkator. Buttelkator said that it's going to bottle the beer, notified the presentator that there's a new beer being bottled, and at the end, it notified that there's a new number of bottles. So we can easily now find whatever was happening. So in this case, maybe it's not that very interesting, but if we had a stack trace at some point, we can track step by step what happened in our application. Okay, so now let's see. There's alerts. Okay. No, ignore me.
Okay, another thing that we can show you is actually Shimano said the cool thing that when you're running your application, for example, locally in a dev mode, you want to play around with it, right? Who of you is using Postman to send requests? Okay, cool, isn't it, right? To remember all the copy pasting of the URLs and stuff, right? Awesome. So why should you do it? I mean, why? So that's why we have Swagger. It comes together with Microinfra Spring. Swagger is creating in runtime the let's say the documentation of your REST APIs. Basically, why should you use Postman? I mean, come on. Here you can pick the proper controller, its method. If you go scroll up, you can see that it's inside ingredients controller. It's the name of the controller in your code. You can send the post method to /ingredients. Then you have response schema, how the response will look like. Here you can click on the request and you can play around with it. For example, let's try to order water. And to the bottom you can click try it out and boom, you have a response. Why on earth should you use Postman if you have such a thing? Another thing that you can use it for, what?
You can save collections in Postman.
That's exactly the reason why you should use Postman. Ignore Swagger.
Yes, so you shouldn't use Swagger. Use Postman because you can have collections.
No. It's
we're trolling.
Yeah, we're trolling.
Another thing that you can use Swagger for is that it actually documents your API, so you can show it to some external companies, teams, whatever. Hey, this is the API, for example. But a much better thing actually would be to show them your contracts, because they can afterwards write their own tests based on those contracts.
Okay, seed.
As we said, we have Jenkins as a code. So we'll try to show you that. We're using Jenkins Job DSL plugin. Yes. So this is just an example because there's a lot of code going on over there, but let's try to take a look at this one. So the first step that we have is actually the build step, right? We build and we produce a jar. So here you can see that we're doing some groovy magic, but actually it's also statically typed, so don't worry, no method missing whatsoever. So we are creating a delivery pipeline. So the pipeline that you saw is called a delivery pipeline in Jenkins. We trigger it, so either someone pushes to GitHub or we poll the SCM each minute. Then we append Slack notification, because actually when the build is in progress, we are sending notification to Slack that, hey, I'm in progress, right? And then the steps that we are doing: clean build, publish, and stuff, right? So we have a Gradle command. And finally, we say that, okay, once you build that, it's okay. We want to, let's say, execute another job, which is deploy to prod. What you see is taking I mean, it's written in the code. It's a Gradle project which you can build, and which is most crucial, you can test it. So you can run up with Vagrant, Docker, whatever, local instance of Jenkins. You can click around on your local instance, see what kind of an XML should be produced. You can play around with the code and see if it matches. And then you can spawn those jobs wherever you are, and you don't have to click anything. So you can go to the code. We're going to show you the slide with the links. You can check it out, and if you have any questions, just ping me, because this is really awesome.
Yeah, and the whole reason for that is that when you start playing with something that's smaller than big services, so small services, microservices, nano services, whatever you call it, then you have a lot of DevOps work that you need to deal now with, which is setting up the new project, setting up repositories, setting up everything, the deployments and so on. And if you have that coded and you can just use some parameters, you can have that with one script, set up everything for a new project, and ta-dam, works. Okay, so I guess this will be it for that presentation part. So we need to show you the last slide, or the elephant. Okay, so if you have any questions, now will be the time. On the screen you can see the links to the above one is the list of all the servers that we showed you just now. And you can go and click. I think we'll leave everything running for a week at least. So you can go click around and see what's happening. Then the second click is all the code that we've written for this presentation. And there is also a link from there to another place that's called Micro Hackathon, I think. Organization that has all the Ansible code and everything for setting up the whole environment. You have our contacts and Twitters.
One more thing, if you're gonna go to Rundeck that we set up, please don't hack it, because I mean it's on Amazon, so if you hack it, you can execute virtually any sort of a command, which is not good. So please try not to hack Rundeck.
Thank you, Marcin.
Oh yeah, I forgot to say that it's on Shimano's Amazon.
It's on SoftwareMill.Just Amazon. Okay.
Thanks.
Thank you.
So if you have any questions, just fire away.